Okay, so what happens in a titration reaction? Well, first of all, in a titration reaction, you have an unknown solution. So let's say we have a solution here, and let's say we have 100 mils of a solution. It's in water. Let's say we have sodium hydroxide in here, but we don't know how much sodium hydroxide we have. And that should be in molarity. So we don't know the molar amount of sodium hydroxide in here. Well, to find out the molarity of the sodium hydroxide solution, we have to have a known solution called a stock solution. So the known solution here, let's say we have a certain volume of, let's say we have 200 milliliters of a known solution of hydrochloric acid. So we have a known solution of like 3.5 molar of hydrochloric acid. So we will be adding this amount slowly to the unknown solution of sodium hydroxide. The solution that we are adding is called the titrant. So usually this is done through a Bure, an acid-base titration. We will add our solution of HCl, 3.5 molar of HCl, to this unknown sodium hydroxide solution. So we'll be able to measure the volume. We'll be able to measure the volume of hydrochloric acid that is needed to add to the sodium hydroxide solution. Now, how do we know that we have added enough of the titrant to consume all of this unknown mixture? Well, we need to put an indicator inside here. An indicator will show a color change when we have a full amount of HCl reacting with all of the unknown solution. So here we have our acid-base reaction. And we will produce water and sodium chloride. So here we have our 100 milliliters of sodium hydroxide solution. We don't know the molarity of it. We're going to add 200 milliliters, our 3.5 molar solution of HCl, to produce this. So when we add enough sodium hydrochloric acid and the indicator color changes, let's say this changes from clear solution to pink, when that happens, that means we have added enough hydrochloric acid to consume all of our sodium hydroxide solution. So I wrote the equation again, just to clarify things. So when we add enough of this, when there is enough HCl added to consume all of the unknown sodium hydroxide solution, the solution turns pink from the indicator, or blue, depending on the type of indicator that you use. But anyway, there will be a color change. So when this color change occurs, we will then know how much of the volume of the hydrochloric acid we have used. We're not going to use all 200 milliliters. So let's say we only use 75 milliliters of HCl, and then the solution turns pink. Okay, so this is a very important number here, because from that number then we can figure out the molarity of sodium hydroxide solution. Now again, when the solution turns pink, what happens at that point? Well, we have none of this left. Like I said, we have none of this left and none of this left. And we just have this, the water and the sodium chloride, and this again is pink from the indicator. So, like I said, we used 75 mils of the 3.5 molar solutions of hydrochloric acid for the solution to turn pink. So, we can do a simple calculation then, figure out the molarity of our unknown. So, we know turn 75 milliliters to liters, multiply that by 3.5 molar amount of HCl, which is 3.5 moles of HCl over 1 liter of HCl solution. We know from the balanced equation that 1 mole of HCl will consume 1 mole of sodium hydroxide because it's in a 1-to-1 relationship in the balanced equation. And going on then, multiply that down. We know so there we get our moles of sodium hydroxide. So this is equal to 0.263 moles of sodium hydroxide. If we divide this number, 0.263 moles of sodium hydroxide divided by 100 milliliters, put that into liters. This is moles over liters. That is equal then to the molarity of our unknown solution. So from a titration reaction, we can figure out the unknown molarity of the sodium hydroxide. Okay, so here we have another titration problem. What is the concentration of calcium hydroxide if 15 milliliters are exactly neutralized by 10 milliliters of a 0.25 molar hydrochloric acid solution? Well, first of all, let's write out the equation for this and balance it out. So we have calcium hydroxide solution plus HCl. HCl is our titrant because it's a known concentration and we are adding it to the calcium hydroxide. So HCl is our titrant. And this will form water, and the salt is calcium chloride. So let's balance it out. So we need, here we need 2 moles of HCl, and it is balanced. Okay. Okay, so it says we have 15.0 mils of calcium hydroxide, and we use 10.00 mils of a 0.250 mole solution of hydrochloric acid. So knowing this, since we know how much of the stock solution we do need, we can turn that into moles of HCl. So liters times the molarity of HCl from my balanced equation. Zero point 0.00125 moles of calcium hydroxide. To figure out the molarity, just what we want. What's the concentration? So 0.00125 moles of calcium hydroxide divided by 15 milliliters, turn that into liters, because molarity is moles over liters, and that is equal to 0.0833 molarity of calcium hydroxide. So this here is our answer.